UK, broadcasting live from London on a very nice May sunny day, and we actually know it's sunny because of how awesome the venue is. I cannot stop talking about it. It's so awesome. My next guest is Deepu. Welcome. Oz Zero by Octa.
Yes.
So there is a hint right there. Oz Zero is cool, used to be cool. Octa, now with Octa, still cool. You mentioned that you spoke about passkeys in your talk, and what I know about that this is the password killer.
Yes.
We won't need passwords anymore because of passkeys. What? How? Why? How does it work? What's going on?
Yeah. So like a TLDR of what I was talking about. So passwords, of course, convenient and everything, but like most of the breaches are credential related, right? Some sort of social engineering or phishing and these kind of things, right? And inherently, because passwords is knowledge based, right? So it's something you know. Whereas passkeys are cryptographic key pairs, so it basically uses the same mechanism as digital signatures. Use a public key pair to verify your identity. I don't want to go into the technicalities of it. That's a longer talk.
Yeah,
right?
I might want to go into technicalities of that because I don't understand why everybody decided it's so secure. Like, so it's basically from the user perspective. I now log into Google or something, and it's like, hey, stop using passwords. Instead, let's save the passkey on your computer, and you will be safe. And I'm like, that doesn't look safe. Like two-factor authentication to me feels much safer because it's something that you know together with something that you have, and it's much more secure than something that is saved on my computer.
Okay, so few clarifications on that, right? So passkeys by nature are multi-factor, as two factors by nature. So in passkeys implementation, so you use an authenticator, either an authenticator built into your device or an external like YubiKeys, right? These authenticators stores these public key pairs, the private key is stored on the device, on the authenticator, on either on the YubiKey or on your TPM or Apple Enclave or whatever it is, right? They don't go out of it unless for sync passkeys, it is synced to an ecosystem. Like, for example, Apple syncs it to iCloud Keychain or Google syncs it to Google Password Manager and stuff like that. Still end-to-end encrypted and safe and everything, right? So the advantage or the safety comes from the fact that this is something you have instead of something you know, plus something you are. So always for a passkeys, you would have to, so if it is on your device, right, you would have to provide your fingerprint or something. So it is the device you have and your fingerprint is something you are. Or if it is a YubiKey or something like that, it is again something you have plus a pin or something you know. So it is always two factors. Of course, you can disable the two-factor thing, but it's not recommended. So by definition or by generic implementation is two-factor. And the most important aspect what makes it safer than password is the fact that it is not phishable. It is phishing resistant. You cannot phish it because the private public key pairs that are being created are bound to the domain. So it will not work on any other domain. So you cannot phish it. And you're not saving any password on a database. You're only saving public keys on a database, and they're public, right? So there's no point breaching your database to get something. You get public keys. What do you do with public keys? Right?
Okay. Now that now makes more sense. So basically, when it says like save a passkey on your device, it relies on the security of the device itself to authenticate you. And then the device will be the two-factor authentication.
Yeah, so the device stores your private key and the public key is stored by your
like Google account, basically.
Okay, there are two types of passkeys. There's a sync passkey, which is meant for general public, I would say, because it is more convenient. You use platform authenticators with that, so your Touch ID or Face ID or whatever. And there is a device-bound passkeys, which is more meant for YubiKeys and these kind of things. So probably more for enterprise kind of use case, because general public is not going to carry around a YubiKey, right? For sync passkeys, there is it's called sync because the private key gets synced in your ecosystem. So if you sign up to something with your let's say iPhone with what do you Face ID, right? iPhone Face ID, then Apple automatically takes that private key from its TPM, puts it in the iCloud keychain, so that when you go into your MacBook, it automatically gets synced to that MacBook's TPM chip, and you have that there, so you don't have to register again there. You can log into the service from your MacBook, but you only registered with your iPhone, right? And it goes on to any device connected to with that account, that particular user account in that ecosystem. Same for Google ecosystem or a password manager like Bitwarden or OnePass or whatever, right? So it's synced, whereas in device-bound passkey is considered golden standard for security because it doesn't rely on. So your private key doesn't go anywhere other than your device. So if you use a YubiKey, your private key stays in your YubiKey, and we know that YubiKeys are secure. You cannot get these keys out of them. So it stays there. It's something you have, and on top of that, you have a protection of either a pin or like a biometric if your thing has a biometric sensor. So it becomes two-factor, right? So it's something you have, it's something you know, or something you are. So it becomes two-factor. So compared to a password, for someone to hack into that, they physically have to be present.
Yes.
To either get your key or like cut off your finger or something like that, which is much more harder than like hacking a database and getting a password. So it inherently becomes much more safe.
I see it. It makes sense. Now, how do you recover a lost passkey or a lost YubiKey if there is no password, so there is no recovery because we want to prevent phishing? But I think it makes recovery impossible or very hard.
For sync passkeys, it's not a problem because it is synced to your provider. So unless you lose your, let's say, Apple account. So unless you lose the Apple account, you still have your passkeys there. So if you lose all your devices, you still get a new device, sign in with your Apple ID, you get your passkeys, right? So for sync passkeys, the recovery, backup, all this is handled by whatever ecosystem you're using. When it comes to device-bound passkeys, there is no standard sync or backup mechanism. So the recommendation is, if you're using device-bound passkeys, have multiple keys registered, which is the same for MFA, right? If you're using MFA with YubiKey, your admin will tell you, hey, have a backup key, right? It's the same. So if you're for device-bound, have multiple keys.
Okay, no, that makes sense. Wow, this is all very interesting. I love it. Taking it to developer perspective, if you want to implement that in your application, how do you get started? What do you do? How does that work?
So there are two approaches to it. One, if you're already going the route of using an identity provider kind of thing, then of course most identity providers will support. Like for example, I work for Okta. Okta already supports passkeys. Auth0 supports passkeys. So you can use that and just flick a button and you have passkey support out of the box with your IDP. If you want to do it yourself, of course you can. If you're using Keycloak, for example, it has passkey support. Or you want to go bare bones and implement from scratch, there are libraries with which you can do that. For example, on the Java world, we have libraries like WebAuthn4j, with which you can implement passkeys. And Spring Security is going to have a native passkey support from, I think, version 6.4 or something, coming out in November, I believe. So you will have native support for passkey. So it will be, as easy as enabling on your filter chain, enabling .passkeys, and you have passkey support, right? So it's going to be that. And there is a huge push for this from all major companies. So it is going to happen.
So yeah, I mean, I guess the main message is passkeys are here to stay. Get used to them, learn how they work, learn how to implement them and how to use them, because this is the future.
Yeah, and it's much more safer than passwords.
This is so cool. Deepu, today we learned, thank you very much. It was very interesting, very useful. And yeah, Spring Security are big news, and obviously Okta and Auth0 is something that you really should start using if you are not. Stay tuned for more episodes of Build Propulsion Lab. Our next guest is right here actually, so we're going to do some switching and we'll be right back with you. Deepu, thank you again.
Thank you so much for having me.